This is question 22 from the 2017 Engineering Admissions Assessment. So this question is about a train collision. We have train A, which consists of 3 locomotives, 130 tons each, and 7 container wagons, 30 ton each. And this train is going at 2 meters per second. In the opposite direction, at 5 meters per second, we have train B with 2 locomotives, 70 tons each, and a number N of 10-ton passenger carriages. The key piece of information, however, is that after the collision, they both come to complete rest. And they're asking how many passenger carriages the second train has, so we are supposed to figure out N. From a physicist's point of view, rest means that there is a zero momentum after the collision. But since we also know that momentum must be conserved, that leads us to the conclusion that momentum must have been zero even before the collision. Remember how momentum is defined? That's mass times speed. So if I write it out, that's momentum in that direction, towards the right-hand side of train A. So that's always the masses here in the parentheses and times the speed. And in the other direction, again, 5 meters per second for the speed times the total of this mass. And you can see that we have our only unknown N hidden here. If we solve this equation, simplifying a bit and then expressing N, we get that the number of passenger carriages is 10, which was letter C.